alaikum, everybody. Thank you for joining. So the session today is on future of agile testing, and so let me set some context first. So I was, you can call it fortunate or unfortunate, that in my very first job, and Kashif can actually attest to that, for about 2.5 years, I had no interaction with any sort of QA. Um, there was no peer review, there was no static analysis, there was no QA cycle, even so far as there was no QA cycle. So and I was for the significant time I was on client side, and most of my work, I had to review it and test it myself, and we would deploy patches to production by hand, and by hand I mean place that file there, place this file there, change this property this. There were some automation, some scripts were written, but it wasn't such so extensive, as it is today, with the new tools that are available. So since there was no QA cycle, I was mostly deployed on client side, and I didn't have any interaction with any QA, and because of that, I did not have any opinion on their ability and capability. But when I used to connect with my peers, they used to uh, undervalue QA. They would not be disrespectful, but were kind of dismissive on the presence in in the project. I personally thought that the QA are, they were generally nice people. They had the same educational background as software engineers, and I felt that they had an equally important role in the project as a software engineer. But I would see a rift, not so much as a rift, but there was always that us versus them concept. Us developers and them QA, us QA and them developers, and developers ने ये कर दिया, QA ने ये कर दिया. It always, there was less feeling of harmony, and there was this rift. So, and I didn't used to get it actually, because I personally thought that they were contributing to the project. But it was later in my career that I started taking interviews. So I realized that um, when I would give a coding or a problem solving question to a software engineer, they would just ace it, but a QA wasn't able to do so, and that clicked with me. I thought that yes, there is some truth to what's happening, and something's being done or not being done by QA, and that is causing the engineers, software engineers, to think less of QA. So what we are going to do today is, uh, and it's not a 1 2 3 point number one, point number two, point number three. I'm actually going to take you back to the roots of agile. I'm actually going to take you back like 70 years. I won't make you stay there for long, but we are going to see some principles of agile, and with specific focus to testing, and why they were considered important in the manufacturing business, and how they can relate even today, and from that build a path towards the future, and connect, and the answer this question of respect, why someone is undervaluing somebody else. So let's begin on the journey of the past. uh, so there is this guy called Shigeo Shingo. He was born in Japan in 1909, and he is attributed to be a major contributor in the Toyota production system. So, for those of you who know the Toyota production system, it is a set of principles, values, and processes to help to be lean, to eliminate waste, and getting things done just in time, and built upon the principles of reviews. So I think the the principal, the person who is really attributed with the Toyota production system, I think it's Tai Tai Taichi Ono, something like that. I think that's the name of the person who was at that time the CEO of Toyota Systems. But at the background, this Shigeo Shingo, he had a major contribution to that system and other optimizations as well. And he wrote a few books, and I think it was in the 80s that people from the US, they started going there. And so from the 60s, 50s, 70s, the manufacturing business of Japan were considered to be really revolutionary, and those were because of these principles. So the people from the West, from the US specifically, they used to visit. They started visiting Japan to find out, what's the differentiating factor, what's happening there. So they met with this guy, and they started translating the books that were written by Shigeo. One of the books that was written by, and actually, before I go to the book, let me just step back for a second. Uh, uh, I was intrigued by how the manufacturing industry. I wasn't intrigued, but I wanted to find out how the manufacturing industry actually tested their systems. So I talked to a couple of those guys, and I said, how do you ensure that the quality of the system is intact? And they said there is a principle called, Shingo. There is a Shingo model. So I started looking into that, and then I came upon, this book that Shigeo Shingo had written, and it's called Zero Quality Control. And so if you so the book title is Zero Quality Control, Source Inspection, and the Poka Yoke System. So the name of the book, Zero Quality Control, that really intrigued me. Like, zero quality control in the manufacturing business, he's trying to set up a system that has zero quality control, that has no quality control. So how is that? So what he did was, in the book, he writes about eliminating the need for inspection of results by doing self review and mistake proofing. He has talked about some principles, which I'm going to, very quickly talk about. And again, those are about not having systems to monitor or inspect what's, it's not about looking at the end product, because at that time, it's delayed. It's about ensuring principles and practices that are put in place, so that without an overall, quality monitoring and quality control system, the quality of the overall system is intact. So if you are so right now, I want you to step out of the developer, or engineering or software mindset. I want you to imagine the I'm sure you're familiar with the conveyor belt model of the manufacturing industry. So the model is, one person specializes in one thing, he makes one thing, and that thing passes on a belt to the next person. That person looks at that thing, he adds his value to that thing, and the thing passes on to the third person. And so there's, on the belt, on the conveyor belt, the item, it moves, and it is slowly and gradually built upon. And there are a lot of other concepts, but what we are interested right now, so I want you to imagine that process, and I want to focus on the zero quality control. And from that, basically, I want you to look at the principle of, so we are talking about the principle that is introduced in the books, that's called source inspection. And in the book, they introduce two types of source inspection. One is self check. So the idea is, you do a process yourself, and then you inspect it yourself. So you have a piece of equipment. Let's say you are supposed to hammer something, or you're supposed to, tighten a screw or a couple of screws. So you do it, and you check it yourself whether the screw is tightened or not. That's a very simplistic example. It may be, it may be a bit complex than that, but whatever you have done, you review it, and then you pass it on to the next person. The next person does his or her work, and then they review their own work, and then it goes along on the conveyor belt. It goes along and along. So self check is reviewing your own work, at this before you pass it on to somebody else. Then there is successive check. The idea is that you process it, you forward it to the next in line person, right? It goes forward in the conveyor belt. That person reviews it, inspects it. If there is some feedback to give, that that item comes back to you. There is a little bit of a waste, but it's still, there is, if you can imagine a hybrid approach of the two, that kind of works. And if there is some issue uh, with something, it will be captured, and it will be fixed immediately, which is something that we'll see later as well. So in the 50s and 60s, the system that Toyota implemented, not look at the car overall, but look at individual screw, whether it is tightened or not. The person should review it themselves, and the person immediately next to them should review the person's work that was previous to them. So that is one sort of inspection introduced in the manufacturing. Uh, this is a complex diagram. I'm not going to go into a lot of detail, but I'll just explain the principle. So the principle here is, if you are trying to manufacture a steel pipeline, some of the work will be automated and some will be manual. If you imagine that this is going across on a conveyor belt, some of the work, as in piercing, passing it through the drill, heating it, stretching it, cooling it, so this work mostly is done, seems to be done automated. And then there is some manual work involved. So on each of these steps, uh, the principle is that on each of these steps, inspection should be done. Okay, so wherever there is some step involved, inspection must be there. The third principle in the book on zero quality control is quick feedback. So the traditional model of PDC, it's called in PMI, it's called plan, do, and check. So it's a good model, it's an effective model, but it essentially revolves around multiple entities. So someone will do the planning, someone else will do the work, and someone else will do the checking. So again, the manufacturing business, Toyota, in the 50s and 60s, they sought to get quick feedback. They said, plan, do check. Do the work, check it immediately. Do the work, check immediately. The feedback cycle should be quick. And so that again revolves around reducing waste. So that's the third principle, quick feedback. This is the fourth and last principle, and it's called Poka Yoke. And it literally translates to mistake profile proofing. It involves the usage of automated machines or devices to prevent mistakes, and it moves and helps towards achieving 100% inspection. So again, we are in the manufacturing industry. The using machines, using automated tools to solve, to ensure, that there is no issue, there is no problem, there is no bug in the system. So that is very important. Right now, I know it's tough, it's too early, but I'd like to ask a question to the audience. So this is, imagine. I've added here the examples of Cadbury and Toblerone in honor of Mondelez. Um, so if and still consider yourself in the manufacturing industry. Imagine you're running, or you're part of a team that is helping uh, manufacture these chocolates. And one of the problems that you have is that you need to ensure that all the packaging that you do, it is ensured that the all the wrappers, all the packets are guaranteed that they are filled with the appropriate candy or chocolate or whatever it is. So I'd like to ask you guys, what do you think should be the right way to test it to ensure that there is candy in the wrapper? So, audience, anybody?
So one way could be just to weight them if they are of the proper weight or not, or
Okay.
maybe a desi style like have fan on the conveyor belt where they will blow off the empty wrappers from the stage or whatever it is.
So both of those are automation, and so there are two aspects to it. The first is have a weighing scale, determine if the weight is above certain threshold, then move it in a certain direction. If it is not, then throw in the bin. Obviously, the fan solution that you mentioned, it is it's you can call it desi, but I would call it a smarter solution as compared to the weighing scale because there is less complexity. So you just put up the fan there. You just have the conveyor belt process it, and wherever there is a wrapper that is empty, that wrapper just will fall off of. You just need an additional bin, and that is all. That is less cost. There is less complex logic. There is no additional management that will be involved. Only a fan and a bin. So the point that I'm making here is the manufacturing industry uh, adds a lot of automation, and they add smart automation. They try to eliminate waste. So that was a quick review of you know the practices of the testing specific practices that were introduced way back in the manufacturing industry. So to quickly summarize, there is inspection, there is 100% inspection, there is feedback, quick feedback, and then there is Poka Yoke. So now we move towards the present. So I want you to come back to the software engineering domain, and we'll talk about the development life cycle. So this is a traditional life cycle that we generally follow. So you start from an idea, strategy, architecture, design, develop, test, release. For the next iteration, from the release you go back to develop, test, release, and then cycle again and again until you get to a support phase. So who can see any issue? Does anybody see any issue with this implementation?
Hi, Salman. I would say that keeping in mind the title of your session, the testing phase is taking place after development, right? So agile testing is about keeping testing in parallel with development, or even writing tests before even writing a single piece of development code. So testing happening after development, I would say that's not something that's the core of agile testing. There should be it should be a step, development plus testing, rather than developing and then testing.
Yeah, so that's my point exactly. Yes. So I think that these two shouldn't be two separate phases. Testing shouldn't be done separate from development. And so to your point, um, we should ensure, we should push towards writing tests while writing code. If it's TDD, maybe even before that, and we should ensure that the gates are appropriately set up and deployments are automated, so that at the end of the day we do not get bogged down in unuseful things, and that we progress fast. So just to illustrate the same point, this is a model that was published by Scott Ambler, and so there's a graph that shows if the feedback that you receive on any item or any task, any story, feedback, whether it's a bug or any change, if it is introduced later in the development stage, if it is in the development stage, it is relatively, the cost to fix it is low. If it is in the QA phase or in the staging phase, again it's low. It's in the UAT, it's low. But if it's in the customer, as the time progresses, the cost to fix it after development it increases, and after that, if it goes into UAT or whatever that phase is, it increases. And even if the customer finds it, the cost is significantly higher. And it is higher because it is difficult to, at that point in time, reproduce the issue, because finding where the issue is, what the issue is, why is it occurring, where to fix it, how to fix it, whether this will create any ripples, and then subsequently fix it, and then ship a release, with all the cycles again. So all of that has added cost and it builds up. So the sooner you find the issue, the better it is. So the approach that is recommended, it's shift left. Get feedback quicker. Don't get feedback in, during acceptance testing, during system testing. Get feedback, during peer reviews, during continuous integration, during deployment pipeline. So all of those feedbacks make sense, and what it does is it reduces the cost, it increases the efficiency. So imagine if a bug is found here, so you as a developer, you are supposed to stop everything, start fixing that bug. That will be higher cost. uh, a lot of your time will be spent on fixing that one small issue, and that same time could be consumed or used on adding another valuable feature, which would have enabled you to get to market faster. So there is a lot of issues with efficiency, quality, competitive advantage. So all of that you get if you can shift left, if you can get the feedback quicker. Similarly, I think all of us know, I think there's been significant talk about levels of testing. Uh, so I'll quickly go through this. I'm pretty sure if all of you know these. There are different variants to this, but I'm sticking with the basic one, which means that at a unit level, the entity should function itself correctly. When two units are integrated, the two units should work correctly. When So that is integration test. When at a system level, when all the integrated units are connected, does the system work correctly? There is system test. And at the top is the acceptance test, which is whether the system complies with the business and accessibility, and acceptability requirement. What's happening with the pyramid is that the width or breadth of this lower half is higher. This means that you add more unit tests, and all of these tests are more reliable as compared to the layers at the top, at over it. uh, the execution time is less. So over here, what's happening is the unit itself, it does not have any dependency with somebody else. So it executes all the tests over here will execute fast. There is less volatility because there is less dependence on somebody else. But as you go to the integration part, since there is dependence on somebody else, changing some unit may impact some other unit, and that may break some tests. So that is what I'm saying by reliability. As you go down this pyramid, the reliability increases. As you go up the pyramid, the volatility increases and the execution time increases. I hope that is pretty self-explanatory. So there are a lot of other concepts that tie in with this thing. The concept of CI/CD. There's a concept of agile testing quadrants. So I'm not touching those here because that will take a bit more time, and I want to get to the other point of my presentation. So so now I'm going to do is I'm going to connect the zero quality control to testing levels. How does the principles introduced, the quality specific principles introduced in zero quality control, they map with the testing principles, or the overall processes. So what I'm doing here is I'm uh, uh, saying that source, and I'm open to feedback. This is just my interpretation. If anybody has feedback, we can talk about that. So source inspection, if it is self check, I'm calling that unit test. If it is successive check done by somebody else, I'm calling it peer review. 100% inspection is achieved in software by writing integration, system, and acceptance test. Yes, somebody.
PR, the purpose of PR is really to test, or is it more to actually review best practices?
Sorry, your voice was breaking out, Rehan.
So my question is around PR and their purpose. Are PRs really, like, can we consider them as part of our testing paradigm, or is this more to sort of, have a second set of eyes, look at your code, whether you're
So they're
designing in the
not
right
directly
way?
related to the testing paradigm. They're not directly related to the testing paradigm. What I'm saying is, uh, uh, so this is what I actually mean. Uh, the four principles of zero quality control, they relate to these four, testing levels on these levels. The other principles, they are, in the software development, they are generic to software development. They are not specific to, testing levels, or they're not specific to testing. But I'm trying to create a relationship between, the I may be forcing the hand a little bit, but I'm creating a synonym of, how zero quality control, how does it translate to software development. So there is no direct relation. I hope that is clear with the, with the circles. So so I'll quickly complete this slide and then we'll move forward. So 100% inspection, to my mind, it is achieved in software by writing integration, system, and acceptance test. Feedback, I have added PR, EPR, ITCR, and TPR. I know people will raise a concern about EPR being quick feedback, TPR relating to quick feedback. I know that that is a valid concern, but I'm trying to, uh, you know, I'm trying to live in an ideal world. I'm imagining an ideal world where we get quick feedback even with EPR, with ITCR and TPR. That is why I've listed them here, because I want that to be a reality someday. Poka Yoke,
So Nancy, what's ITCR?
it's internal test case review. It's what the team does
Okay.
about the test cases that are written, and they review it. The team reviews the test cases internally for completion and correctness. Okay. So TPR is testing practice review. So Poka Yoke is talking about automation. So I'm adding static analysis here because adding a lint, getting the analysis, getting that report is kind of, an automated process to my mind. And then obviously there is CI/CD. uh, and this is my mind. This is my map of things. There may be something that I'm missing here, and if anybody has feedback, I'll be really happy to talk about that as well. So looking to the future, what does the future hold for us? Uh, so I believe that uh, I'll come back here. So these are all the things that we are doing today. We have started writing unit tests. We have started doing PRs. We are talking about the quality of the PRs. There is significant talk about writing integration, system tests, maybe not acceptance tests, but I think we are getting there. At least the discussions have started. Let's talk about the PR, and all the reviews are there. A lot of teams have started using static analysis. They're relying on that. I think we are trying to push people towards using uh, the analysis, the numbers that they get from those reports, in their retrospectives as well. So I think we are trying to go over there as well. And obviously there is CI/CD. We can't live without that. So this is the current state of the system, that Confiz at least is at. So this is an area where I think we need to really invest. There is lesser knowledge about it as a whole. I'm sure a lot of architects know about it, but as a whole, there needs to be an understanding of what load, stress, soak, spike testing are, How does load differentiate from stress? So can spike, and what tools should you use to do either of these, and what are the best practices? If I so I'll quickly and briefly talk about these. So I'll try to explain what my understanding of performance testing is. So the four types of performance testing that I have listed here are load testing. Essentially, you put a significant load on the system and see how it responds, see how it behaves, right? If so, the purpose of this is to see the system behavior. The purpose of load testing is not to break the system. Whereas stress testing, the purpose is to break the system. You're actually trying to see when and where and on what parameters your system will break. And obviously, there is no one parameter. You will have to apply it from different variations. And again, that's where a stress test plan comes in. Soak test, or endurance test as it's also called, is putting the system under sustained load for a longer period of time and seeing how the system behaves. If it is a bigger system, if it's not a monolith, if it's something else, uh, what happens to does the overall system perform okay over sustained load, or do you identify a bottleneck? That is, let's say one of the services went down but the rest of the system was okay. So that is a bottleneck to my mind, and you would try to improve and fix that one bottleneck and basically try to improve the system overall. And then there is spike testing. So you just add significant load suddenly. So imagine running I think Aved was talking about it yesterday. We were doing a project for a customer, and we had produced an Instagram like the live stream feature in there. The people could do chatting as well. So the customer did not inform us. That was not part of the plan. We had not done any sort of stress testing or anything, any performance testing, and the owner of the company, he went live in front of 8-9,000 people. This before COVID, so he went live before eight. No, sorry, this was just at the start of COVID, I think. And he went live in front of a lot of people, and he started sending quizzes and started sending messages. So suddenly we had a significant number of users who immediately started using the stream feature, the live streaming feature, the video streaming feature. They started using messaging system. So there was a certain spike in on our monitoring tools. So spike testing, it what it does is it tests the system from that perspective. What if a lot of people get onto the system suddenly? How will your system respond to that? So these are different types of performance testing.
Salman, I will add the bare bone performance test as well. For me, the bare bone performance test is without a load how the system is performing, because we have seen many websites, many mobile apps who with even a one user will run very slow. So I would think the most basic type would be just checking how out of load if system is meeting the benchmark of response times.
I totally agree. Yes, that should be part of this entire endeavor as well. Yes. Let me say what you just said in a different way. And again, we were talking about it yesterday. What is our API response time? Is it like a few milliseconds, hundreds of milliseconds, or thousands of milliseconds? That's essentially what you're saying. So this is a direction where I think we need to go towards. We need to build our knowledge and expertise of tools, and identify best practices, how to get them in place. uh, this is another avenue where I'm
Question.
going to. Yes, please.
When you say we, does that mean we Confiz or we the
Rehan, your
software
voice is
unit?
breaking out too much. Sorry, I can't.
Um, so is it any better?
No, it's not.
Let me switch.
So I'll just go through the rest of the slides. I don't think there is too much content there. So this is kind
Is it
of sorry.
better now?
So is it me? It shouldn't be me because I'm in the office, and if
Yeah,
I'm
Rehan
not
is
able to,
waiting.
No,
yeah.
Rehan's internet has some problem.
Rehan, maybe आप type
Yes.
करते हैं and then we can read it
Yeah,
out.
So Rehan,
go ahead. Go
Rehan, I think you should disconnect and then reconnect. That's a persistent problem with you. So
Yeah,
try
I mean,
reconnecting.
reconnect part is optional.
No, it's not. No, it's not. He has his session. I think tomorrow or day after. So he better join these sessions.
So while
ahead.
Rehan is, yeah. So
Yeah.
while
I was just wondering. No,
now
sorry.
it's much
Go
better.
ahead.
Yes, yes. You sound like a human now, quoting Steve.
So I was just wondering when you say we, does that mean we, the software community at large, is going or should be going towards this, or are you saying we as in Confiz needs to think about these testing types?
Uh, so I think this information should be known and understood to Confiz at large. I think as a specific skill set, and I'm going to talk about it at the end of the talk as well. I think this is a specific skill set that the test engineer needs to bring. This is the value that they should bring to the table. This involves different types of test strategy formulation. This involves understanding of what the system is built on, whether it's a Docker or it's a container or it's a it's under a VPC. What sort of infrastructure is there? There needs to be an understanding of even the VPC. So there is a background knowledge that the even the testers must have. Building on that, they must understand what tools they need to. So first of all, the understanding the difference between all of these. Then the usage of tools. What tools? How to use those tools? What's the best strategy? What's the test plan? What's the execution strategy? What's the load strategy? What's the stress strategy? So all of those need to be figured out. And specifically, this is the skill set that the test engineer needs to bring to the table. But at large, everyone at Confiz should actually know about this problem as well. So I'll quickly move towards this testing, security testing. I'll so there was so much material, there was so much stuff, uh, so much information about security testing that I actually got lost here. I couldn't actually summarize as well as I was able to summarize performance testing. So I'm leaving this part open-ended because my own knowledge is less. What I can tell you about security testing is there are various ways to enter the system. So there are different parts to the system. There is backend, there is the client side. There are various ways to enter the system via physical access, via the internet, via network. Uh, uh, so there are various ways to access the system, and subsequently there is the following things that so there is compliance issues that people need to be careful of, they need to be aware of, whether it is PCI, sorry, this shouldn't be PCA, this should be PCI. There is database security, who should have access to what, in whether it's a schema level or table level access. Then there is cross-site scripting, cross-site request forgery. There is so much information, and there are so many types of testing. There are different types of vulnerability assessment. There is ethical hacking. There is penetration testing. Uh, at the core, uh, the principles that security testing tries to address are the confidentiality of data, its integrity, its authentication, authorization, and availability. That's at a very large what the principles are. And there are so many techniques, so many tools out there. This is the last slide. I'll we'll probably go a few minutes over, but let's wrap it quickly. So I think कि मैंने ये वाला question kind of answer भी कर दिया, but I'll still like to hear from the rest. Whose responsibility is it to test? Anybody? Fazan.
Um, I guess it should be every individual in the team. We shouldn't be labeling like the QA person. Everyone should be able to test and write automated tests.
सही है जी,
ये
आप
वो
पास हो गए
सोफिया
आप
का
एक
क्वेश्चन है जो गोलकीपर वाला क्वेश्चन पूछते होते रहता।
यार मेरे ख्याल में जिसने कोड लिखा है उसकी रिस्पॉन्सिबिलिटी है। मतलब अगर आपने टेस्ट ही नहीं किया तो आप डिलीवर कैसे कर सकते हैं? इट्स पार्ट ऑफ
so that is exactly my point as well. If there is one thing I want you to take away from this session, it's these two things. Team owns the quality and the quality is built in. Testing is for everyone. It is true that there are some specialized areas of a software engineer, software tester that the software tester focuses on, like performance and security testing. But the team overall has to own the quality. They have to ensure that they test it themselves, whatever they are presenting, that it is state of the art. And so let me connect it back to the initial question uh, that I had in my mind. Why are uh, QAs being, in my experience, why were QAs being treated less? I think it was because they were just writing test cases and executing those. तो उसके अंदर कोई बहुत ज्यादा क्वालिटी वाला या बहुत ज्यादा प्रॉब्लम सॉल्विंग वाला काम नहीं था. I really believe that respect must be earned. So I think that the responsibility of test engineers should be that they raise their hands, they start understanding the problem, contribute to solving that problem, write code, whether it is at a system uh, component, sorry, not component, but integration, whatever level that is, whether it is to address, identify performance issues, solve those, whether it is identifying security issues, help resolve those, all of those uh, are the things that the test engineer must do in order to gain the respect of the team. अच्छा यहाँ पे I'll there's a short video. I wouldn't take very long. Just give me 1 second. So there is captions at the bottom. I hope you can see that as well. Previously it was manual labor and Jansen actually lost his life because of it.
I designed this to come off, so... Ow! Hey! Gosh, you... Please try not to move. Hey.
I know it's not exactly canary, but so I should have actually said
Thank you
that
for reminding me,
spoilers alert.
Confiz.
I should have actually said spoilers before I started this movie, and apologies to the DC fans. And this clip, Iron Man doesn't include any. He doesn't show all the test gates. that he would have implemented in order to achieve the level of automation that he got. But the what I want you to take away, the other takeaway is, I want you to become Iron Man, automate as much as you can, as fast as you can. And if Iron Man can write code to automate his work, why can't you?
Yeah, I have a question. So very creative use of Iron Man video here, and thanks to Sohail for helping in the video. But I have a question, Salman. I think you were collecting some data around. Okay, हमारे पास मैनुअल टेस्टर कब तक रहेंगे और कब तक चलेंगे?
I don't think manual will totally go away. I think people will have to realize that where they need to add value, what they are bringing to the table. If they can do that, they can add some value using manual work as well. So manual will probably not go away, but uski jo scope hai, I feel that will diminish. I think जी wrap up करते हैं. Thank you very much for participating. उमेर